Everyone, and welcome back. So we're looking at exponential and logarithmic functions, and we're doing a review on exponents and exponent laws before we jump into kind of exploring exponential and logarithmic functions. So let's first look at reviewing the laws. So we're reviewing the exponential laws. So when we're dealing with exponents, there are a few laws that we want to keep in mind, like the product law, where if I multiply two bases, and before we even do that, let's kind of just talk about what is the base and so on. So when I say my base, the base is what's underneath, so that this x, the exponent is the one on top, right? And putting it all together is our power. So if I say all of this together, that's our power, okay? All right, so let's use this information to kind of do these laws over here. So when we talk about the product law, over here we can see that they have the same base, right? So with these laws, it's generally going to be if they have the same base, then we're going to apply a certain law. So over here they have the same base, x times x. So if I say, for instance, 2 to the power, 2 to the power of 3 multiplied by 2 to the power of 5. The way we do this is we say, okay, since they have the same base, then we're going to just use that same base and we're going to add their exponents. So it's going to be, for instance, over here, oh, sorry, that same base over here is x. But in our case over here with this example, it would be 2. We add the exponents, and so it's 2 to the power of 8. Here it would be x to the power of m plus n, because we don't know what m plus n is, so it simplifies to m plus n. And then when we have a power of a power, so what does a power of a power look like? Power of a power is basically saying I have a power and I'm raising it to another power, right? So over here I have x to the power of m. Here's my first power. Now I'm raising it to an n exponent. And so this power of a power tells us that we actually multiply these exponents, right? So I have x to the power of mn. So m multiplied by n. And if this were an example like 2, it would be 2 to the power of, let's say, 3. All to the power of 4. So this would equal to multiply these exponents would be 2 to the power of 12. Okay? All right. So let's have a look at then power of a quotient. So when I'm talking about power of a quotient, here I have division, right? So over here, I just have a quotient inside. Remember, quotient just means fraction. So I have this fraction and I'm raising it to a power. All this means is that I'm going to apply this power to each of the elements of that quotient. So the numerator as well as the denominator will get the same exponent. And so over here will be x to the power of m all over y to the power of m. Okay? All right. What if I'm looking at the integral exponent rule? All right. So what does that mean? Over here, if I have x to the power of something negative, right? So if I have, for instance, 2 to the power of negative 3, how do I apply this? Well, basically anything to the power of a negative exponent, I just flip, all right? So if this is over 1, I flip it, or I just bring this, I technically just like bring this 2 to the denominator. All right, so I go, oh, okay, well, that's 1 over 2 to the power of a positive 3. All right, so you bring the base to the denominator and then you give it a positive power. So over here, it's going to be 1 over x to the power of a positive m. Now, I don't want you to confuse something like this. If I have, for instance, 2 over 3, and 2 has to the power of negative 3. I'm not going to bring that 3 to the top because the 3, nothing is happening to it. All I'm going to do is I'm going to bring this base 2 to the denominator. So I'm going to go 1 over 2 to the power of 3 multiplied by that 3 outside. All right, just don't confuse it. You're not bringing anything in the bottom to the top. You're just bringing the base to the bottom. And if it's in the bottom, then you're bringing it to the top. All right, just reciprocating that base, this base of 2. Okay. All right, so let's have a look at the next one. Just keep in mind that x has to be not equal to 0, because if I'm bringing it to the denominator, I need to make sure that I'm not going to have a 0 in my denominator. All right, let's have a look at the next one. The next one over here is a rational exponent. So I don't want you to confuse this with power of a quotient. the power of a quotient, you have already a fraction to the power of something. Rational exponents is I just have a base to the power of a fraction. Okay, so over here, here's my base, x, to the power of this fraction m over n. The way we do this is we say, oh, okay, well, because they're being divided, then I'm actually going to subtract them. Okay, so remember with product rule, when they're being multiplied, oh, sorry, my bad. So over here, it's x to the power of a fraction. And so we could say, you know, it's the root, okay, the nth root of x to the power, all to the power of m, okay? Now, let me show you this in action. So you've seen this before, like if you had x to the power of 1 over 2. Do you remember how we write an exponent of 1 over 2? We can write this as the square root of x. Why can we do this? It's because this goes towards here. This becomes the index of this root, and this one becomes the power of what's inside of the base. Okay, so anytime I have a radical, anytime I have a rational exponent, so let's do another example, y to the power of 3 over 4, for instance. The bottom one becomes the index of the radical. This one becomes the power of the base. All right, so let's have a look how this would look like. It would be the fourth radical, right? Because we're saying this becomes the index, which is this number sitting outside. And then y gets that power of 3, okay? All right, now we should have actually looked at this a bit sooner. The quotient law, we should have looked at it right after the product law. So the quotient law is basically what happens if I multiply powers of the same, if I divide powers of the same base. Now over here, I'm saying, listen, you're dividing, this should have not been a square root, this is just a division sign. You're dividing x to the power of m by x to the power of n. When I multiplied, I added them. When I multiplied powers of the same base, I added their exponents. When I divide powers of the same base, I subtract their exponents. So I go x to the power of m minus n, okay? All right, let's look at the next one. The next one is power of a product. So when I have two things being multiplied and I raise them to the power of something, it's just like what we did with the quotient. I apply it to both. Okay, so this becomes x to the power of m, y to the power of m. I just apply it to both of them. Okay. All right, so that's the review of exponent laws. Let's have a look at changing the base. What happens when I want to change the base of my radical? Sometimes I can do this if I have something like let's say I have something like this. So I'm telling you, you have 16 to the power of 3, for instance, okay? And I tell you, you know what? I want this to have a base of 2. All right, how can this have a base of 2? So here's the question. Rewrite this with a base of 2. All right, well, if I would do this, I would say, okay, well, how can I have 2 instead of 16? Well, 16 can be written as 2 to the power of something, right? 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16. And so I can go 2 to the power of 4 instead of 16, right? I'm just replacing 16 with 2 to the power of 4, which is basically the same thing, all to the power of this 3 that was already there. And so now we've produced this one over here. We've produced a power of a power. And so we can rewrite this as 2 to the power of 12. All right. And so over here, what I've done is I've rewritten this by changing the base. I've changed my base and written it as a base of 2. What if I asked you to write it as a base of 4? Well, you can do that as well. You can go, okay, if I want a base of 4, how would I do this? Well, a base of 4, how can I write 16 as 4 to the power of something? I can go 4 to the power of 2. That's my 16. And then all to the power of 3. And so, again, power of a power, that's 4 to the power of 6. All right. So I can change the base only if I'm able to rewrite the base as something to the power, like whatever I'm trying to change it to. to the power of something, okay? All right, so let's have a look at solving equations with rational exponents. Now, we've done this before, solving equations with rational exponents, but let's have a look at some comments I've included here. So use the following procedure to solve equations where exponents are rational. All right. Now, if you have a rational exponent, what does that look like? We've already talked about it. It looks like this. All right. We have a base and the exponent is a fraction. So it says raise both sides to the reciprocal power of the exponent. Let's see what that means, okay? The reciprocal power of the exponent, if I had something like this, right? Let's say, oh, this one over here, right? So Sarah completed this by taking the cubic root. We're not even going to worry about like what they did. We're going to do it ourselves. So let's crop this. Bam. Okay. All right. So we're going to look at solving this ourselves. So over here, they had 4/3 to pi r cubed is equal to 50965. All right, so this is the equation they started with. And they wanted to solve for what is this r? R is in this case radius, but they're asking us, or they're asking, how do we find radius? Now, the way we do this is, yeah, we want to do this, but we can't do that yet because we want to isolate for it first. This assumes that we have something like this. X to the power of 2 is equal to 520, for instance. I don't know, whatever. And then it says raise it to the reciprocal exponent. So something like this. The reciprocal of 2 is 1/2, like that. All right. Cancel, cancel, because they multiply. X becomes 520 to the power of 1, all square rooted, right? But we're not going to do that yet. And over here it says simplify and solve for the variable. Yeah, basically what we did right now. But we can't do that right now in this scenario because we want to isolate first for this radius. We want to have a variable to the power of whatever is equal to something. So don't jump into using these two steps over here until you have a variable on its own on one side with to the power of whatever is equal to something. And so in this case, we would cross multiply, get rid of that 4/3 by multiplying by 3/4. Bam, bam, bam. We'd have, oh, and we're going to want to get rid of the pi as well. So cross multiply that pi as well. So we're going to have radius cubed is equal to 50965 multiplied by 3/4 pi. All right, now what does this simplify to? Not exactly sure, but that's okay. We don't have to simplify to a value right now. I'm just going to show you the steps. So now that we've separated it, we have a variable to the power of something is equal to a number. Now what we want to do is we want to raise this to the power of the reciprocal. So if this is 3, we want to raise it to 1/3. So I'm going to go 1/3, cancel, cancel with this 3, right? Because you multiply them. And now I'm sitting with a radius to the power of 1 is equal to all of this stuff raised to the power of 1/3 as well. But do you remember how we do that with a rational exponent? We said that we write x to the power of m with the nth root, right? So we go over here. This stuff, don't have to simplify it for now. 3 all over 4 pi. All to the power of 1, but cubic root. All right, you simplify that and you find what your r is, basically. All right, everyone. So that's it for this section, reviewing exponents, knowing how to use exponent laws, and solving equations with rational exponents. This is pretty much it for this section. So join me in the next section where we're going to talk about the next topic in this section, in this unit. Bye.